All right, for today we're going to look at chapter 20 and 21. So we're going to talk about static electricity and electric fields. So starting with chapter 20, static electricity, we're going to talk about specifically what electrostatics are for section 1. So electrostatics, your definition is that it's the study of an electrical charge or charges that can be collected and held in one place. So these can be stored. So when I say a charged object, you can have like charges and those are going to repel each other, or you can have opposite charges and those are going to attract. Kind of common sense. You guys should remember this from previous science courses. So for example, if you run a comb through your hair, especially in this time of the year, right, you're going to get a lot of static and frizz. So we have a couple of terms. Conductor is the first. It's materials that allow charges to move freely through them. So think about metals. And then we have insulators, and that's the opposite. So charges do not move easily or freely through those. So glass, dry wood, most of your plastics, cloth, and dry air. Section 2, electric forces. This is where we're going to get into our formula for today. So forces, what you need to know, there are two kinds of charges. Just like I said, there are positive charges and there are negative charges that you can have. And we'll get more into that when we look at our formula. And charges, just like with Newton's third law in motion, they're exerting a force on each other based on a distance. Okay, so the closer they are, the greater the force. So an electroscope, you guys will need to know what this is and you will need to know how one works. So when you finish the video today, if I can get your attention, we'll do a short demonstration. So it's a device that's determining charge. It doesn't tell you whether it's positive or negative. It just tells you that there is a charge. And like I said, we will do a demonstration with that in just a little bit. So here's your formula for today, Coulomb's law, and this is one of the scientists that one of you had for your paper. So you have the magnitude of the force between charge of object A and the charge of object B, and they are separated by a distance. So what we have for Coulomb's law is this. Force is equal to K, that's Coulomb's constant, multiplied by QA, QB, divided by D squared. Okay, so force, that's in newtons. K, that's Coulomb's constant, and that is 9 times 10 to the 9th. And then it has that set of units behind it so that those units will cancel out and give you just newtons. Okay, so Q is the charge of the objects. That'll be in coulombs, so that'll be a capital C. And then D is your distance in meters. So here's an example. Two charges are separated by 3 centimeters. Object A has a charge of 6 or positive 6 microcoulombs, while object B has a charge of positive 3 microcoulombs. I want to know what is the force on object A. Well, we only have two objects in play here. So force on object A is equal to the force on object B. And we're going to use this formula, of course. So we're just going to plug in our information. K, that's 9 times 10 to the 9th. QA, positive 6 microcoulombs. Now this is what you need to know. What is a microcoulomb? Okay. So if you look at chapter 1, where we talked about conversions, micro is actually 10 to the negative 6th. So what I like to do to make things nicer, I just like to plug it in as 6 times 10 to the negative 6th. Okay, does that make sense? And this should actually be right here. This should actually be 10 to the negative 6 as well, not negative 3. I'm not sure why that's in there. So we have our object A, we have QA, we have QB, and then we're going to divide by D squared. And again, this is in centimeters. It needs to be in meters, so of course we'll convert. And when you go ahead and plug this in as it sits, again, make sure you use 10 to the negative 6th. You should get roughly 180 newtons. There are some practice problems that I want you to do. It's page 1296 in your iBook. It's number 9 through 14. You can work on those now, or you can come back after the video is finished. But let's go ahead and move on to chapter 21. electric fields. And there's not a lot in this chapter, just some basic ideas that I think you should know. What is an electric field? It's a vector quantity, so it has a magnitude and a direction. It relates force exerted to the size of the charge that's being tested. And we have electric field lines, okay, and it's the direction of the field at any point drawn as a tangent, okay. So if we have a positive charge here, your field lines are going to go away from the charge, okay. If you have a negative charge, your field lines are going to be drawn in toward. Okay, so if this line wasn't here, you could clearly see that a positive is attracted to a negative because those are going in the same direction. Okay, these two arrows are pointing in the same direction. Whereas if it was a negative and a negative, the arrows are pointed opposite. And if it's a positive and a positive, the arrows are again pushing against each other, pointing in opposite directions. Okay, and that's it for today.